Students, we will start with first law of thermodynamics. So here you can see there are three different ways by which you can express first law of thermodynamics. First is energy of universe remains constant. Second, the total energy of an isolated system is constant. Third is, you can interpret this way, energy is neither created nor destroyed and can only be converted from one form to another. So this is very well-known statement, that is, energy can neither be created nor destroyed and can only be converted from one form to another. Now if you apply this whole thing, you can say this way: if energy is supplied to the system, that increases its internal energy. Means if energy is supplied to the system, there will be increase in internal energy. So increase in internal energy of the system. Secondly, whereas removal of heat or work from the system, it decreases its internal energy. Means removal of heat means again removal of energy. In other words, you can say if energy is removed, that is removal of heat or work from the system, it results in a decrease in internal energy. Decrease in internal energy of the system. Third thing you can write, increase in internal energy. So you can write here increase in internal energy. Increase in internal energy of the system. Increase in internal energy of the system. This is equal to sum or addition of, this is sum of quantity of heat. Sum of quantity of heat supplied to the system. Quantity of heat supplied to the system and plus, that is, amount of work done on the system. Work done on the system. So this is nothing but, you can write in other way, that is delta U equal to Q plus W. As I already explained in earlier videos also, you can determine the value for delta U, but you cannot go for U1 and U2. You can watch my earlier videos also. So you will come to this delta U equal to Q plus W. What is this Q? That is the amount of heat supplied to the system, and this is the amount of work done on the system, which is denoted by W here. So this is the mathematical expression for first law of thermodynamics. Now further, if you apply this first law of thermodynamics to various processes. So first we will start from the first process. You can write here, that is isothermal process. So as the name suggests, isothermal process means temperature should be constant here. So process is carried out at constant temperature. So temperature is constant. In such process, internal energy is also constant. So delta U will be equal to 0. Now what is the actual thing what is happening to keep this delta U equal to 0 or delta U is constant? Because you are keeping the temperature of the system constant. I have already explained this in earlier videos also. I'll just repeat in a moment. If you take a container and you take some amount of water here and you are adding here concentrated acid, so there will be, this is an exothermic reaction, so naturally there will be increase in the temperature. But if you want to keep this at constant temperature, you can keep this beaker in cold water, so the temperature of the system can be maintained. So this is an isothermal process. So there will be no change in the internal energy as there is no increase in the temperature. Now for the isothermal process, if you apply this delta U is equal to Q plus W, this is first law. Here delta U equal to 0, so 0 will be equal to Q plus W, or you can write W is equal to minus Q. So heat absorbed by the system is entirely used for doing work on the system. Here there is an absorption of heat. Here suppose it is used for doing work on the surrounding, and that results in the no change in the temperature here. So that is why delta U equals to 0. Now when I say W plus W, it means that work is done on the system. Work is done on the system, of course by the surrounding. When I write minus Q, it means that release of heat. Heat is released from the system. Release of heat by the system to the, of course, to the surrounding. Now we can explain this isothermal process or first law of thermodynamics in isothermal process. You take solid ice here. Solid ice is taken, and if you are supplying some energy to this ice cube, what will happen further? It would be converted into liquid form. It would be converted into liquid. Here it is at 0 degrees Celsius, and so the amount of energy which is absorbed by this ice, that is utilized for the conversion from solid to liquid state. So solid is converted to liquid at 0 degrees Celsius. So the temperature of liquid would be here again 0 degrees Celsius. There would not be any change in the temperature. So temperature is constant here. While converting from solid to liquid, if some amount of energy is supplied, that is used for the fusion. So this process is called as fusion. In simple words, we can call it as melting of ice, but in scientific way we call it as a fusion. So here W is equal to minus Q. Energy supplied is not stored in the system. So this energy which you are supplying to this system, it is not stored. On the other hand, it is utilized for converting this solid into liquid, and that is why delta U equal to 0, and this is occurring, this process is occurring at constant temperature, that is 0 degrees Celsius. So therefore there will be no change in internal energy. There is no change in internal energy, means delta U equal to 0 here. Now in coming back to the next thing, that is second process, that is adiabatic process. So in case of adiabatic process, as you already aware that in case of adiabatic process there is no exchange of heat. No exchange of heat. There is no exchange of heat between system and surrounding. Between system and surrounding. So in this case, that is, you can write, that is Q will be equal to 0. So when you apply this to this equation, delta is equal to Q plus W. So you can write Q equal to 0. So you can write here, when this Q equals to 0, you substitute value. So delta U is equal to 0 plus W, or you can write the same thing as delta U equal to W, or minus delta U will be equal to minus W. Now as the process is adiabatic, increase in internal energy of the system, it is the work done on it. That is, if internal energy is increased, if there is increase in internal energy, means you can write here increase in internal energy, that is having positive value. If it is plus delta W, that is there will be increase in internal energy. Then work is done on the system by the surrounding. Work is done on the system by surrounding, means you will have positive value for W, that is plus W. If work is done, second thing, if work is done by the system on the surrounding, so second thing you can write as if work is done by the system on the surrounding, by the system, of course on the surrounding, means this is work of expansion which is denoted by minus W at the expense of its internal energy. The internal energy, that is delta U, internal energy of adiabatic process will decrease here. So whenever there is decrease in internal energy, it would be minus W. That is why we can write minus delta U is equal to minus W and plus delta U equal to plus W. So this is about the adiabatic process. Now come to the third point, that is isochoric process. That is third, that is isochoric process. It means that process is carried out at constant volume. Isochoric process, in this particular, it is volume is constant here. So as the reaction is carried out in a closed container, remember this is important here. If you want to maintain the condition as isochoric process, it should be carried out, the reaction or the process should be carried out in closed container. So volume of the system will remain constant. Means if you take a container, it is fitted with the piston. Yes, you screw this piston over here so that there should not be any expansion and the volume of the this system would remain constant here. So the container should be a closed one. So in this case, delta V will be equal to 0. Here we are talking in terms of volume. We are talking in terms of volume. So we will have to take into account this work done equal to minus P external into delta V, because we are very much in context with the volume change. That is, though it is 0, but we will have to consider this volume here. So next thing we are having delta U is equal to Q plus W. This is the first law. Now when you apply this condition to this first law, you will get delta, this is U, delta U is equal to Q minus P external into delta V. Now here, as we already know that delta V equal to 0, as this is a isochoric process, so you can write here delta U equal to Q. So this Q, that is the heat supplied to the system, you can write at constant volume, so you can write here QV. Okay, so this is about the isochoric process. So this is the important thing you got over here. Here in case of this adiabatic process, you are getting two situations, minus delta U equal to minus W and plus delta U equal to plus W. Now we'll proceed for the last one, that is the isobaric process. So chemical reactions carried out in an open container. So all the chemical process which we carry out in chemical laboratory or chemistry lab, all these are isobaric process. So isobaric or isobaric process. So these are carried out in an open container. This is carried out in open container under constant atmospheric pressure. So atmospheric pressure is always exerting, always exists on the reactions which we carry out in chemistry lab. So at constant atmospheric pressure. So in such reaction, delta V will not be equal to 0. There can be change in the volume. Means if you take a reaction there and if you are adding reagent, there can be or there will be change in the volume against a constant atmospheric pressure here. So you can write W is equal to minus P external into delta V. So there will be change in the volume, though the temperature is constant here, because we are carrying out the process in an open container. Okay, so next is delta U is equal to Q plus W. This is nothing but the first law of thermodynamics. So when you combine these two things together, we'll come to the equation delta U is equal to QP minus P external into delta V. So we have just substituted the value for this W here. Now in terms of QP, what is this QP? That is heat supplied to the system at constant pressure. So QP is equal to delta U plus P external into delta V. Okay. Now up till now we were saying that Q is nothing but the heat supplied to the system, which is denoted by capital Q. So heat supplied to the system, and small q, this is the heat flux with respect to unit area, here. Okay, so here you can write Q is not, small q is not a state function, so its value does not depend on the state of the system. It is not state function, it is independent of the state of the system, whereas QP, that is heat supplied to the system at constant pressure, and QV, that is heat supplied to the system at constant value, both of them are state function. These are the state functions, means their values depends on the state of the system. Okay, so here comes the concept of enthalpy. This is what is the enthalpy of the system. So actually what is this enthalpy? It is the sum of internal energy of the system and the energy equivalent to PV type of work. So that is the QP is equal to delta U, that is the internal energy of the system and the energy equivalent to pressure volume type of work in the system. In other words, you can say enthalpy is nothing but the total heat content of the system. That is total heat content of the system. So we reach up to this concept of the enthalpy. This concept we will study further in the next lecture. Thank you.